Good morning, children. So see, today we will see mechanical advantage, velocity ratio and the efficiency of single fixed pulley. So see here, this is the single fixed pulley. Already you knew about the construction of single fixed pulley. This is the disc which is fixed through the rigid support. And here, this is the string. One end of the string load is suspended and the direction of the load is in the downward direction, and we know the string always tension force is acting along the on the string. So see, tension force direction is away from the load, so load is equal to tension force T. Other end of the string, here effort is there, and this effort is also acting the downward direction. By the effort, it can pull the string in the downward direction by this person. This person is pulling the string in the downward direction. That's why only the load moves up. So tension is equal to effort. So we can write here effort is equal to tension. From these two equations we can write load is equal to effort. Now one more thing, we will have to neglect here the mass of the string. This is the string, and mass of the string we will have to neglect. One more thing we will have to neglect, that is the friction at the axle. Then the pulley is in the balanced. Now in case of the single fixed pulley, you can see we know that mechanical advantage is equal to load by effort. So load by effort, here load by effort, load as it is tension came and effort is also tension came. From the figure we know that load is equal to T, effort is equal to T. So we can write here mechanical advantage is coming 1. So this arrangement is the no gain in the mechanical advantage. Mechanical advantage is equal to 1. We know that whenever mechanical advantage 1, that time only the direction is in the convenient direction. Load and effort both two are having in the downward direction. So from here, velocity ratio, the displacement, the distance moved by the effort divided by the distance or the displacement moved by the load. So how much portion effort is coming downward direction? Load is same as it is, same distance covered by the load. So d by d, distance moved by the effort arm by distance moved by the load arm, d by d is equal to coming 1. So velocity ratio and mechanical advantage both are coming 1. Efficiency eta, mechanical advantage by velocity ratio, it is coming 100%. But it is not possible here. Always some friction at the axle or in the pulley is bearing. This pulley and the axle which are having some friction is also. So effort is needed is little more than that of the load is lifted. Somehow it is possible. Effort is needed little more than the load. So mechanical advantage is less than 1, but velocity ratio is always 1. Velocity ratio is always 1 because distance moved by the effort and distance moved by the load, it never change. But mechanical advantage can be changed, which is less than 1, because some friction is possible here. And if some friction is possible, then mechanical advantage is less than 1 and it is always less than 100%. It is not possible for all the machines or the actual machine or the ideal machine. So we can see here a single fixed pulley is used only to change the direction of the effort to be applied. With its use, that is, with its use, the effort can be applied is more convenient direction. So you can see effort, we will have to do the effort is in the downward direction because for doing the work very easiest way only. That's why only we are using the single fixed pulley, and always we are trying to mechanical advantage it must be one. This is only for use to change the direction of the effort, because it is very problematic whenever the direction of the effort is in the upward direction. This is the against of force of gravity. So we need to give the effort which is in the downward direction, which is supports the force of gravity. So it is difficult to afford here upward to lift a load up directly. It becomes easier with the help of the fixed pulley. Effort can now be applied downward direction to raise the load up. Further, to apply the effort downward, one can conveniently make use one's own weight also for effort.